fancy! Now that we've had some experience with our logarithm properties, let's go and solve some equations. Okay. Moving up here. Yes. Okay, I've isolated a logarithm. Now what do I want to do? I want to 3 it up. What? I want to get the same base. Yeah, I want to 3 it up. Okay, sure. On the left, you see you have a special property. Some general properties of logarithms. Log base b of 1 is 0 every single time. Log base b of b is 1 every single time. Log base b of b to the x is x every single time. Log base b to the log base b of x is x every single time. Sure. So we use that special property, 3 to the log base 3 of x is x. And then on the right, 3 to the 4th, yeah, that's 81. Fun. And then what? But before I leave this example, I want to say, you're not really 3ing it up. You're actually exponentiating both sides with the base of 3. Right. But I like to say 3 it up. It's more catchy. And, yeah. Okay, so then I need the isolated logarithm. So I need to divide both sides by 5, or I can take that up to the exponent of the argument. But no, I'm gonna divide both sides by 5. So I see I have the natural log of 2x is equal to 20 divided by 5 is 4. Sure. So now, what do I need to do? I need to e it up. Yes. Why? Because that's one of our special logarithm properties. Special logs. Yeah. If there's no base written, it's log base 10. Your common logarithm. We're on a base 10 system. The natural log, ln, log natural, is really log base e of x. So then I e it up. What you do on the one side, you must also do on the other. I'm exponentiating both sides. So left on the left side, e to the natural log of 2x is 2x. And then on the right, that's e to the 4, sure. Now, I'm a fan of exact answers. So, I'm gonna take it up here, divide by 2, and find that x is equal to e to the 4th over 2. And then what? A box. And a flower. Let's cruise up here to our next example. All right, I'm looking at that and it doesn't look nice. Why? Because I don't have my logarithm isolated. Okay, so then I'm going to isolate this logarithm. I subtract the 6 off each side and I have 2. Natural log of x is equal to a minus 1. Fun. Still isolating that radical. Okay, dividing both sides by 2. Then I have the natural log is equal to a minus 1/2. Natural log of x, that is. Great. Now we get to e it up. What you do on the one side, you must also do on the other. Using my properties, this is the, oh no, natural log is gone. Yeah, sure is. But what's left? X. Oh, nice. And that x is going to be equal to e to the minus 1/2. Yes. Caught me yellow-handed. Down here. Ooh, big ones, no whammies. Stop. I see I have the difference of logs, so I'm going to use one of my special properties. Some properties of logarithms. The log of a product is the sum of the logs. Yeah. The log of a quotient is the difference of the logs. Yeah. And log of the argument to the r power is r times the log of the argument. Okay, I'm going to combine those logs. Let's see, I have the log of the difference. That's going to be the quotient of the logs. So then this is going to, or the quotient, the log of the quotient. Yeah, rough. Speak in morning. Log of 3x minus 5 divided by 5x. That's going to be equal to 2. Now what do? That's one of my special logs, isn't it? That's the common log. So then I'm going to want to 10 it up. I 10 it up. Yeah, what you do onto one side, you must also do onto the other. Because when you don't see a base there, it's the base of 10. So 10 to the log base 10 is 3x minus 5 divided by 5x. It does give you the arguments. And my argument is that's equal to 100. What bothers you about that? The fractions. How do you clear fractions? Multiply both sides by a common denominator. Here I'm going to multiply both sides by a 5x. What you do onto one side, you must also do onto the other. Yeah. So I multiply this side by 5x, and I multiply this side by 5x. Right. Now we need to be careful for a solution of 0, because that's going to be a domain restriction. Divide. I guess I should have subtracted that off and done it all that way. But, yeah. Okay, cruising on. 3x minus 5 is equal to 500x. Wow, that's mighty big. I'm continuing to solve that down. I got x's on both sides. I only want them on one side. Which side? Right-siders, come out and play. Minus 5 is equal to 497x. Wow. Okay, so then x is equal to a minus 5 over 497. Now, see, I get numbers like that, and I'm thinking I live in a nice numbered world in these algebra books, so maybe I should check it, plug it back up into the original. In fact, I want to plug it right here. Okay, we know we have a domain restriction for a logarithm. Right. You can't take a log of a negative number. So when I plug this back in here, does it work? It does not, because that makes it a minus 25 and 497ths. Right. So this does not work. What does work? No solution. Come on. There you go. Some of you guys are like, nah.